doesn't stand out as being one of the major categories because if you look at the data, it's not. Okay, this was brown. I'm just going to give room to write it in there. And that was 8%. Okay, go to the last stopping point, measure out the 20, and this is the last measurement that we'll have to do to take care of the rest of it. Okay, this one should be 20, no, 72. 72 degrees is about right there, and draw the line. Okay, orange. 20%, and that should leave the 17, or the 11% for the yellow right here, which was 40 degrees. If you measure that, it should come out really close to the 40. Which is okay. That's how to accurately get the circle graph. If you were to just make a sketch of that, it's not going to be real accurate. It probably wouldn't look as close as it does on the red and blue because unintentionally you're going to try to make the blue section bigger, but in the visual it really, you can't see that it's bigger unless you pick this up and then all of a sudden you see the difference between the two. But they're so close with 79 and 83 that on a circle you really don't see that clearly. Okay? But those are the ones I see skewed the most, and they're skewed on purpose. Because people are trying to say something with the graph that they produce. Okay? Questions about any of these graphs? So the circle graph is the most intense one, but it can have the most impact depending on what you're trying to say.
Do you want us to use a protractor like on homework and tests?
You won't be creating one.
Okay.
Yeah. I might have you do calculations leading up to one, but I'm not going to make you draw it just because protractors will get into it. That's
just
the next
finding
class.
like the percentage
Yeah.
degrees.
That part I want you to know how to find. But actually using the protractor to draw it, I can't really assume that you know how to do that until after you have Q1 and 3. Okay? All right, we'll see you next class.
What if there is?
What number?